So this is my main transformer for my high voltage side of the amplifier. I had an issue where it wouldn't hold voltage and it kept popping fuses. So I got to looking and I figured out that one of these windings here, this winding here that I've got the clip leads on, it's running to the Simpson over here, and it's either shorted or sort of shorted, because what happens is if I tie them together like it calls for, this is a transformer out of a let's see, this is not Hallicrafters, it's a Hammerland HXL1 transformer, and they show the transformer right here being tied together, black and red tied to black and yellow, and black and green tied to black for 120 volt usage, instead of if you do 220 or 240, you tie the two center taps together. I mean, you tie the two legs together and you have the two outsides. Well, on 120, you're supposed to tie the two sides together in parallel so that you can take advantage of both windings being in there. But what I found is when I do that, it kicks a 15 and a 20 amp fuse, just blows them. I mean, blows them bad. And so I decided to take it apart, take it open, and see where the short was, or if it was in the right here where it's soldered. And it's not. It's somewhere down in the windings, and it's on this side that this is tied to. The 120 coming in is coming off of a variac down here on the floor, tied to this side. This side's got the Simpson on it, showing the shorted turn. This is the one that's shorted. It's still putting out voltage. It's acting like an isolating transformer winding. So you're putting 120 in, you get 100 volts out, something like that. It's almost a 1-to-1. But what I noticed is it almost has no resistance. When you test this with a ohm meter continuity test, you get like 0.2 ohms. So normally on a primary winding you'd have half an ohm, 0.5 or 0.6. But what I found with this is this winding has like 0.2, 0.1 ohms. It's nearly a dead short, so it's burn up somewhere inside. The other side is a 0.5, which is exactly what it's supposed to be. And so what I decided to do was run my 120 off of this side and see what the volts come out on the high voltage. So that's what we're doing here. This meter, if you can see it, let's see if the light will come on. There's the light. I don't know if you can see that, but right now it's showing 001. I'm going to plug in the variac and crank it up slow to 120. And the Simpson meter, I always sit back from these because this lead's going to be handling 800 volts. And so if it had a cut in it, you're going to get it. So, alright, so my variac's on, and you see with the variac all the way down, it's showing 1.5 volts on the high voltage side. And with the variac all the way down, this side's not showing anything. So let's start cranking it up. Alright, so right in there is where it's supposed to be for 120. And I'm showing 806 volts on the high voltage side, with just that one winding being used as the primary. And I'm showing 100 volts coming out of this side here. So it is making voltage, and I'm just going to cap it because it's doing me no good. Yeah, I got no reason for it. I'm going to try one more thing. I want to make sure I'm putting 120 volts into it, so I'm going to turn all this off. And I'm keeping a steady 800 volts AC, which is going to rectify to slightly more than that, rectified with diodes, a bridge rectifier. And but I'm using a doubler circuit. Oddly enough, same doubler circuit that's in here. I have three diodes. I have my capacitor bank, ties in here, doubles it out, should be about 17 or 1800 volts. Time it was done, that's what it was doing before it messed up. And I was worried I was not going to be able to use this transformer. I might still not be able to. It might not pull the amperage. It only has to have, 500 milliamps. That's what I need, 500 milliamps. That'll give me a buffer of about 50 milliamps. So we'll see how that goes. I've got this off. I'm going to take these clip leads off, and I'm going to see if I'm putting out 120 here. So we're going to clip on. Make sure we got continuity. I don't have continuity. That's kind of odd. I bet it still puts out voltage though. Oh, I was on AC, that's why I didn't have continuity. Let's see here. Yeah, there we go. Half an ohm. Alright. Yeah. You gotta remember with these Simpsons, you got all the switches and stuff. So let's see what we do. Actually, I'm getting more out of here. So there's about 120, and I'm getting 900 volts out. So 120 in, 900 volts out. I'm going to call that good. And it may not be the full capacity of this transformer, but the original transformer was pulling two 572Bs, and I am not pulling something that big. I'm doing the 4-125s, which I believe are a little bit smaller transformer. So, but anyway,